which is a mass M is hanging from a crank, as you see here in question 17, from point C shown below. The crank is supported by a frictionless hinge at point B and a horizontal force applied here, which is 20 newtons at point A. Now we can actually solve this in using two separate methods. Firstly, we could use the components of a force, or second, we could use components of a force, and second, we can use the true moment arm method. So true moment arm method. What I'll do is I'll solve it both ways and we can actually compare the results, and hopefully they are the same. Now, the first way we'll do it is we are actually going to find the component of the force that we have. So we have two forces here. We have M pointing down and 20 kilonewtons pointing this direction. We want to find the component of the force which is acting perpendicular to the moment arm. And the moment arm here, if you see, that's our first moment arm. We have the distance of it, which is, or the length of it is 350. And our second moment arm is the 900 along here. Sorry for the messy writing. And therefore our second equivalent or force we're trying to find is over there. Now I'm going to make sure these arrows are a bit more to scale once I draw them, but at least now you get the idea. So for our first force over here, we can create a triangle. And we know that this 20 kilonewtons is the largest force in this triangle. And how we're going to find the force acting in this direction is simply by some trigonometry. So if I create this triangle again over here, we have this here, and we know that we are going to have 30 degrees. We're going to have a long force here, and we're going to have a right angle up here. Okay, so if we know that this is 20 kilonewtons, we know this is 30, we know this becomes the adjacent, this becomes the opposite, and by using that, we know that this is now 20, this adjacent force here is 20 cos 30 degrees. Okay, so we can find that adjacent side, that adjacent force by using some trigonometry. So that's our first force. Our second one is unknown because we have M, but let's draw out the triangle so it makes it a bit clearer. We have this line here, which is our M. So remembering this is our largest force, so it should always be the largest line. And therefore, I need to make sure this is a right angle there. So if I think of it that way, this becomes a right angle. Therefore, this is the hypotenuse. This is our M, and our 30 degrees sits in here. So if we think about it again, we have our adjacent, our opposite, and our mass. So this simply becomes M cos 30 degrees, which is interesting that we have cos 30 in both of them. That actually makes it a bit simpler once we do our calculations. All right, so now that we have our equivalent forces, the rest of the part becomes quite straightforward. We simply need to work out the sum of the moments about B. I'm going to do around this direction. So we have our positive is going to be our 20 kilonewton force, should equal to 0. And that's going to help us find B, our mass M. And I am aware that we're dealing with a force and a mass, but I'll come to that in a second. So our sum of the moments around B is 0. So 0 equals, positive was 20 cos 30 degrees. And that is obviously going to be multiplied by the moment arm, which is the perpendicular length, which is simply 350. And in the opposite direction, our moment becomes the force multiplied by our distance is M cos 30 degrees multiplied by 900. Now this is where it becomes interesting and simplified, because if we bring M onto this side, M cos 30 degrees times, we'll do 900 M equals 20 cos 30 degrees times 350. And we divide by 900 and cos 30. We get 900 cos 30 degrees. You can see why it's going to simplify a little bit. We actually get to cross out these cos 30s. And we end up with 7,000 over 900 as our force. Remember, these are kilonewtons. So therefore we have, it's 7.77 or 78 kilonewtons. And remembering, if we want to turn that into a mass, we need to divide that by 10 or by the gravitational pull. So I'm going to do 10 meters per second squared as my assumed gravity. And therefore we have 0.7778 kilonewtons or 778 kilograms. Now that's our first method. I'll show you how to do the next method if you're interested in the next video.